I had some students ask questions about just not understanding anything in Chapter 3, so I thought I'd work through some problems. So the video's online. The book can be read either online or in the physical form. So I'm not sure what else to do except maybe try to work some problems that students would encounter. So here's some problems we'll do from 3.1. Here's the first one on 3.1. Indicate whether the statement is a simple or a compound statement. If it is a compound statement, indicate whether it is a negation, conjunction, disjunction, conditional, or biconditional by using both the word and its appropriate symbol. So here's the statement. If the game is not sold out, then we can get tickets. So it's an if-then statement. Well, that is definitely not a simple. This has two statements. We have the game sold out, is sold out, we can get tickets. Those are two statements. So this is going to be a compound. And let's see. It doesn't give me the option to... Yeah, okay, I guess that's it. I thought it was going to give me the thing where I had to say what type. Oh, I guess here's continue. And then if the statement is compound, is it a negation? Well, there is a not in there, but the not is not controlling the whole thing. It's only controlling the first part, so it's not the negation. Not a conjunction, so it's not an and, it's not an or, but it is conditional. So conditional is that one. Yay! Okay, so that's it. That's what we had to do. Let's skip to maybe number 5 of this section. Write the negation of the statement. Some cats do not have claws. So we're looking for the opposite of some cats do not have claws. So we have choices. Not all cats have claws. Well, that's kind of saying the same thing as what we saw. No cats have claws. No, it's not quite the same. Or not quite the opposite. Some cats have claws. Well, if some do, some don't. So these are really the same thing. And I know that this is the negation of that, but really. Okay. All cats have claws. Let's check that. Hey, there we go. So the opposite of some do not would be all. All have. Okay, let's skip maybe to number 10 here. Just see what that looks like. Let P and Q represent the following simple statements. P, I get an A. Q, it is snowing outside. So write the symbolic statement, the negation of, and we have parentheses, P and Q. So the negation means we'd start off with it is not the case, or it is not true that. And we see it is not true that, it is not true that, it is not true that. So it's going to be one of these three, the first, third, or fourth. Then we have P and Q. I get an A, and it is snowing outside. So it is not true that I do not get an A and it is not snowing, so that's not going to be it. It is not true that I get an A or it is snowing outside. Well, that's not it because it's an and. It is not true that I get an A and it is not snowing. So it is not true is going to apply for the entire thing, and that's that negation symbol. There we go. Let's pick something else here, maybe 13, then we'll do 17. Okay, it says here, let P, Q, and R represent the following simple statements. P, I eat bananas. Q, the job pays well. R, the play is boring. So write the symbolic statement in words. So we have the opposite of R, or not R, the negation of R. So that means the play is boring. The opposite of that would be the play is not boring. And there's an if then, so it's an if then, because it's this conditional symbol. If the play is not boring, then Q, the job pays well, and P, I eat bananas. So if the play is not boring, one of these two, then the job pays well and I eat bananas. Must be B. Hey, we got it right. Let's look at 17. For the statement below, perform the following. Write the statement symbolically by using parentheses. Determine whether the statement is a negation, conjunction, disjunction, conditional, or biconditional. So, you may take this course if and only if you did not fail the previous course or you fail the placement test. So P is you may take this course. We know it's going to start with the P. Then we have the if and only if. So it's going to be one of these two have the if and only if. You did not fail the previous course, so Q is you failed the previous course, so it's going to be a not Q. We have the not Q. Or you failed the placement test. Or so it is one of these two here. So let's just see how we're joined together. So given that the comma is here, makes me think these thoughts are together and this one is separate, so I'm going to go with A. That's correct. Yay! Okay, so that's the idea behind doing these. Oh, is there more to do? Oh. Is the statement in part A a negation, conjunction, disjunction? Okay, so you see here, the negation is not controlling the whole thing, it's just that one statement. The or is controlling those two. So the overall thing is that it's a biconditional statement. Okay, so that's kind of sampling of problems from 3.1. Let's look at 3.2. Okay, let's try number 1, start there. Okay, fill in the blank. The negation symbol, the negation, not P, will always have the blank truth value of P. So if P is true, its negation will be false. If P is false, the negation will be true. So it'll always have the opposite of P. Okay. Let's try another one. Okay, this is interesting. We're gonna fill this in. So we have P and not Q and not R. So we're gonna do P and not Q first when we do this. So if P is true and Q is true, not Q would be false if Q is true. So we're talking about true and not true, or true and false. The and means they both have to be true. So the first part's false. And so we have false and not R. R to be true, so not R is false. So false and false means the first part is false. Second case, again, true for P. Q is true, so not Q is false. So it's true and false. So this part's false, and not R. R in this case is false. The opposite of false is true. So it's false and true. So we'll call this again false, because for an and to be true, they both have to be true. Now we have true and not false. See that one, false there? So not false would be true. So this is true and true, meaning the first part's true, and not true means false. So it's true and false. So that's still false. Now we have true for P, false for Q, false for R. So true and not false, that means true and true, means this first part's true, and false, we have not false, because R is false, not false is true. So it's true and true. We have our first true. Everyone cheer. Yay! Okay, next one. P is false, Q is true, R is true. Well, if Q is true, not Q is false. So false and false is false. Not R. Well, R is true, so not true is false. So it's false from this part. False from that, so the whole thing is false. Now we have false and not true. See, it's Q is true. False and not true. So false and false. That's false. And P is false, so not false is true. So we have false and true makes it true. Now we have false and not false. So false, not false. Well, that's false and true. An and with a false and a true is still false. And then R is true, so not R is false. So false and false is false. I think that last one should have been a false. Look at that again. It's false and not true is false. And yeah, that's right, because it ends up being false for the first part, true for the second, false and true is still false. Now we have false and not false and not false. So false and not false. Not false is true. False and true is false. It makes that first part false. False and not false, meaning false and true is still false. So we only had one true out of that whole thing. Okay, let's go up to 9. Okay, determine the truth value of the statement R or not P or Q. Now remember, in the R case, the pair is true if just one of them is true. Using the following conditions. P is true. So P is true, so not P is false. The first part's false. Q is true, so that part's true. R is false. So we have false or false. That makes the first part false. Or true. So just one of these has to be true. Since Q is true, it makes the whole thing true. And then the second case, P is true, so not P is false. Q is false, R is true. True or false makes that true. True or false makes the whole thing true. Okay, that's how we do it. Let's do 11 and we'll do 14. Use the table to the right to determine the truth value of each simple statement. Then determine the value of the compound statement. So the statement is, country B produced more feature films than country E, and C produced more feature films than country D. So we have the B produced more films than E. B is 510. E is 2247. Yes. So the first part's true. It's an and, so the second part has to be true for the whole thing to be true. C produced more films than D. C is 409, D is 413. That part's false. So we have a true and false, so this would be false. Oh, what did I do wrong here? Oh, did I read this wrong? What's the truth value of the first simple statement? I was doing the whole thing. Okay, truth value of the second one is false. And good. And then the overall thing would be false. Let's head and read the instructions well. Okay, let me do a similar problem. I like to get these right. Okay. Country E produced more feature films than C, so E's more than C. E more than C is false, because C had more, so. And then, final check on that. And then, how about the second part? Country A produced more feature films than D. Does A have more than D? Yes, it does. So what we have is a false and true situation. False and true is still false. Yay. Okay. Looking at 14. It says, write the following compound statement in terms of the simple statements P, Q, and R, where P is I pay the bills, so I pay the bills, that's our P, or take the kids to the park. I take the kids to the park is Q, so it's P or Q. And my wife would be happy. My wife is happy as R. So it's P or Q and R. So notice how they're separated with the comma there. That means the P or Q would be together. Then the and R is going to be separate. So it looks like it's C here. P or Q and R. Okay. Oh, there's more to it. And then we want to construct a truth table. And we have P. I only have the two choices, P or Q. So P or Q. If Q is true, P is true and Q is true, it's true. If P is true and Q is true, it's still true. Okay. So the final compound statement, when we have the first part or and are, they both have to be true. So the first part's true, and then the are's true, it'll be true. If the first part's true and the are is false, it's going to be false. There's more to it. Okay. T or F, true or false, means true. Just one has to be true. True or false is still true. Now we have the first part's true and the second part's false. Sorry, second part's true, so it's true and true. They both have to be true to be true. First part's true, the second part's false. That's going to be false because it's an and statement. See the and? Good there. Now we have false or true, so that's true. False or true, so that's true. Now the first part's true, the second part's true. True and true is true. First part's true, the second part's false. True and false is false. Okay, last part. We have false or false, the first part's false. False or false, the first part's false. And then it's false and true, so it's false. False and false, so it's still false. Oh, there's still more. Okay. Use the truth table to indicate the set of conditions that make the compound statement true or state that no such conditions exist. So we see it's true. R has to be true for it to be true. See, that's the case. So the statement is true when, now notice P or Q are true, it'd make it true, and R has to be true. P or Q is true and R is true. See, it's not just when they're all true, because there's a case when P might be false and Q is true, or P is true and Q is false. Oh, this is or. That doesn't work because there are cases when they're both false, and that's true, it doesn't work. This isn't true because one of them can be false. So P or Q is true and R is true. So let's check that. There we go. And that's it for that section. I mean, there's more to do. I've just done a sampling of problems again. So let's go on to 3.3. So fill in the blank with the appropriate word, phrase, or symbol. The conditional statement, if P then Q, is only blank when P is true and Q is false. So it's only false when the first part's true and the second part's false. Meaning like you fulfilled the first part, but you didn't fulfill the second part. Okay. Fill in the blanks for the missing values in the table. So if P is true, not P is false. Q and R, so we have true and true, so that's going to be true. So if false, then true. If false, then true. The first part's false, the second part's true. That's a true statement. Yay! Okay, let's go up to 9. Oh. I don't want to leave the question. Oh, there's more to do it. Okay. Now, if P is true, not P is false. If let's see, we have true and false, so that's false. So it's conditional. If false, then false. That's false. That's still true. Still true. Didn't meet the one condition we had, that the first part has to be true and the second part false. So we have false for P. False and true is still false. If false, then false is still a true statement. I know that messes people up a little bit. And we have false. False and false is false. That's still true. Then we have the opposite of false is true. So now we're reaching the case where the first part is true, so the second part has to be true for this to be true. True and true is true. If true, then true is true. So we have true. Now true and false is false. If true, then false is a false statement. So you fulfilled the first part, but not the second part. Like I said to my kid, if you clean your room, then we can go to the movies. He cleans his room, we don't go to the movies. Then I lied. Oh, I did something wrong. I said false, I just didn't click false. Okay. Now again, we have true for the first part. False and true is false. If true, then false is still false. One more. True, false, false. There you go. Now let's go to 9. Okay. Determine whether the statement is a tautology, which means always true, self-contradiction, which means never true, or neither. Not Q and P if and only if not P. So P if and only if not P. If P is true, not P is false. Now, biconditional is only true when they're the same thing. They're both true or both false. So the second part's always false. No matter what Q is going to be, this part's always false. This is like saying it's sunny if and only if it's not sunny. Well, that's never going to be a true statement. So, given that it's an and, they both have to be true, so this will never be true. Okay, if P is true and Q is true, R is true, find the truth value of the statement. So, P is true, not P is false. So, false if and only if true, that part's false. If Q is true, not Q is false. So, false if and only if true, that's false. False and false is false. Okay, let's see. The bar triplets have an annoying habit. Whenever a question is asked of the three of them, 2 tell the truth and the third lies. When asked which of them was born last, they replied as follows. Katie was born last. Katie says, I am the youngest. And Anne says, Mary is the youngest. Okay, so who is the youngest of them? Who was born last? So, let's see. If at first glance, 2 of them are lying, one's telling the truth. No. 2 tell the truth, one's lying. So this one's saying Katie was born last, and Katie confirms she's born last. It means those 2 statements are confirming each other. This one is the different one. So it looks like Katie was born last. Okay. So there you go. It's a sampling of 3 questions. I hope that helps people to get started with this. And let's look at 3-4. Statements that have exactly the same truth value in the answer columns of the truth statements are called equivalent statements. Those are equivalent. Use De Morgan's laws to determine whether the two statements are equivalent. So the negation of if P then not Q. Okay, well, if P then not Q would be, look up De Morgan's laws. I thought it was the opposite of P or not Q. I think if P then Q would be P or not Q. So we have a couple of negation issues to work out. Let me confirm De Morgan's laws here. I like when we can convert between conditional and go to a, where is that? Yeah. Okay, the negation of if P then Q would be, that's equivalent to P and not Q. Well, since it'd be P and the opposite of whatever this one is, the opposite of not Q is Q. So this means they are equivalent. Yay. That was page 132 in the textbook. Use De Morgan's laws to write an equivalent statement for the sentence. The cat does not have 9 lives, or the dog does not have teeth. Okay. So we can also look at De Morgan's laws if you look in your textbook on page 129. And I wish I could write on this, but I can't because I'm doing the problems. I'm not on my other program. Need something to write on though. It's going to be, the cat does not have 9 lives, so not P, or the dog does not have teeth, not Q. So meaning the P is the cat has 9 lives, Q the dog has does have teeth. So the negation or the equivalency for this would be the negation of this conjunction P and Q. So it'd be, it is false that, so it's going to be one of these first two. The cat has 9 lives, and see the or when you use De Morgan's laws becomes an and the dog has teeth, so it'd be B. Okay, write the converse, inverse, and contrapositive of the statement. So if you vacuum the rug, then you can play video games. The converse just means to change the two. If you can play video games, then you vacuum the rug. So you swap the P. If P then Q, you do if Q then P. That's converse. Okay, continue. Inverse means you just negate the first and the second. If you do not or cannot, if you did not vacuum the rug, then you cannot play video games. So there you go. Next one, the contrapositive. This means you switch them and you negate them. So if you cannot play video games, then you did not vacuum the rug. So the video game one goes first and you negate it. The vacuum one goes last and you negate it. So it'd be A. Okay. Let's go on to 17. Determine which, if any, of the 3 given statements are equivalent. Use the information about a conditional statement's converse, inverse, or contrapositive. De Morgan's law is the fact that if P then Q is equivalent to not P or Q, or the truth tables. If I am daydreaming, then I hear the announcement. It is false that I am daydreaming and I hear the announcement. I am not daydreaming and I do not hear the announcement. So which statements are equivalent? So I'm going to convert this first one. I mean, we should put them all symbolically. The first one says if I'm daydreaming, so let's say P is I'm daydreaming, and Q is I hear the announcement. So our first statement is going to be if P then Q. Second one, it is false that I am daydreaming, so not P and I hear the announcement, so Q, not P and Q. And then C says I am not daydreaming, so not P and I do not hear the announcement, not Q. Well, if you look right up here, it says if P then Q is equivalent to not P and Q, or Q, excuse me, and we have that. A is if P then Q, B is not P or Q, so it would be A and B. No, I didn't do that. Something's wrong there. Let me just check it again. Okay, if I'm daydreaming, then I hear the announcements. If P then Q. Oh, I didn't see that. It's false that I am daydreaming and I hear the announcements. So that second one is a negation out in front of P and Q. So in that case, those are not equivalent. Likewise, B and C are not equivalent because they're both ands. If one was an and one was an or, they would be equivalent by De Morgan's law. So I'm going to say E. None of the statements are equivalent. There we go. Okay. So see, even I don't read things through thoroughly the first time. So there you go. That's a good sampling of the problems. I'm hoping that's enough to get some people started. Let me know. This video's I'm going to go ahead and end it here. It's been 32 minutes. Wow. Talk to you guys later. Bye.